Hello, everyone. Good morning, good afternoon, good evening. We are missing someone. We are missing Akansha. Normally, Akansha would join us, but she's actually out this week. She's dealing with something on the personal side, so sending her good wishes and positive vibes all the way throughout. She'll be back with us very soon. Dan, Leon, how are you both doing?
Yeah, doing well. The weather's finally improving in the United Kingdom. Been an exciting week last week as well. So yes, it's been good.
Wait, did you say you were? What were you doing last week?
Oh, there's that's the general election in the UK last week. So
That's
it's been
fun.
all changed. There's been a lot happening in the United Kingdom over the last week, but the sun's shining, the weather's improving, so it's all good.
That's always a good thing. That's always a good thing. Leon, how about you?
It's raining cats and dogs here today. So just enjoying that.
Nice. I love it. Okay. Dan, I think I saw you climbing on some sort of
Yes, yeah.
cliff
So
or rock.
I live quite close to the countryside, so I was out climbing with a friend over the weekend, and some random guy kind of sauntered over, going, "I've been taking photographs of you." I was like, "Okay, that's interesting. Would you like copies of them?" So yeah, gave him my email address, and he sent me over the photos that he'd taken. And yeah, I was quite proud of a photo that he'd taken whilst I was balancing away on the side of a rock. So yeah, it's good climb. Enjoyed 6A plus out in the Peak District.
Love it. All right. I am just getting some stuff ready here. Yeah, I tried to I've tried to be a little bit more consistent with the climbing. I'm trying to aim for about 2 to 3 times a week. I feel like 3 times is like at the limit because you just need time in between to recover
and let the skin regrow as well.
Oh yeah, that too. Like I started noticing like my Mac OS is not reading my fingerprints as well
No.
anymore.
I get that, especially outdoors on Gridstone. I come back in, I just can't log in. So that's my excuse for not really getting any work done in the afternoon.
That's always fun. Well, everyone, thank you so much for coming by today. And this is stream number 11 on some of the networking stuff we're doing in the cloud native space. So I want to thank you all for hanging with us and joining us and just being a part of the conversation. The last time we streamed, we actually, we dug into some BGP bits and how that works in Cilium. And we just because we do a lot of things on the fly at times, I honestly don't spend a lot of time preparing. I just like to show up and we just do our thing. We just realized oh no, this is Cilium 1.15 and it has nothing to do with any of the CRs that we talked about. So today we actually will be showing you some of those CRs, and we'll actually be doing this in a lab environment too. Outside of the academy, we're just doing this in a Linux box. Fun story. I spent some time last week actually building out a home lab because I was having a lot of analysis paralysis, right? I was deciding, do I want to deploy bare metal Talos? Do I want to deploy some other, version of Kubernetes or something like that? And then I began to realize that, for what I need, for what I'm doing most of the time, I definitely need just a virtualized environment, something like a cloud-like environment. So I ended up deploying Proxmox on my NUCs. And it was probably the easiest thing to do because you just download the ISO, and as long as you've got allocated IPs and a network, it stands up. Clustering is super easy. There's some additional advanced stuff that I'm trying to get to, like the SDN stuff, as well as getting a SEP cluster up and running so I could do some really cool distributed storage, because I've got a lot of storage, but it's all local. It's local storage, and then that also creates a problem, especially when you're trying to do migrations or you're trying to do some high availability. If you have a workload that fails, let's talk about vSphere, for example. When you have a workload that fails, if you didn't have shared storage, well, your workload is not going to come online in another node if that node lived on and originally failed. So the shared storage approach allows all hosts in a cluster to see the common or shared storage. They could see the contents of it. They can see all the virtual machine artifacts. And then if a node fails, there's logic built into the vSphere clustering system to say, well, okay, this workload's no longer active, restart it on a new node because you could still see the storage. So that's what I'm trying to get to, and I'm debating whether or not I want to do iSCSI or NFS or something. Just it's like one of those another analysis paralysis kind of deals. But for the interim, I at least have something that works and got me to a point where I can deploy a VM and test out some of the basics of what I need. So that's going to be your lab environment today. I deployed a Ubuntu VM, and what's really cool is there's been a lot of work that's gone into getting BGP up and running. In fact, I'll even show you a quick repo, a nice little repo that's kind of hidden. I don't know why it's so hidden, because especially if you're really in the network engineering space, this is probably going to be very applicable to you and also be very familiar as well. So if you want to head over, and I'll paste this in the chat. Let me just drop it in here so y'all can get it. In that little repo here, you've got a few different labs. In fact, if anyone's interested, I probably will never get to it in time. The prerequisites need to be updated a little bit just to match how this automation flows. And it's just because Make requires some dependencies. So Kind, Container Lab, kubectl, Helm, as well as Cilium, the Cilium CLI. So what ends up happening is you actually also need to deploy Make as well, or install Make. But what happens is there's a file that just basically steps you through how to install the environment. So you're not manually deploying your own cluster, installing Cilium yourself, or you're not having to sit there and deploy like the BGP artifacts. But I'm going to walk you through it. We're going to walk you through what these artifacts look like. So you get a lot more familiar with how to work with BGP. And then if you're running, let's say some Cisco or Juniper or HPE or whatever gear in your environment, and you need to interface with the Kubernetes environment, well, we're going to show you how to do that. So I want to point out a few things because there's so much you can do with the BGP functionality within the control plane for Cilium, but there isn't a lot in terms of use cases documentation at the moment. It's still being worked on as far as I know, and I'm going to do some testing myself. But right off the bat, right, there's a few things that there are some examples to consider. So you'll see multi-homing, pod IP pool, and service. Now let's talk about pod IP pool for a second. Now, one of the things that you probably will do in an environment is set up the HCP of sorts, and normally this might be for your nodes, because when your nodes come online, they just need an address to be able to communicate on the network. Same applies in Kubernetes. When you spin up a workload, it's going to get an IP from an IP address management system. In our case, it's going to be Cilium. Now, you can be a little bit more definitive about what IP addresses get handed out, and that actually can be influential in how the rest of your network can access those workloads, because you're going to use BGP here in the mix. So what that means is, hold on, I got an unread mention here. Now I got to go check it out. This is what happens. There's Dan. Mac OS just panicked. Oh, okay. That's kind of why Dan just disappeared. In any case, I'll keep going. So one of the cool things about the BGP protocol is you can exchange networks between your physical environment and your virtual and containerized environment. And this might be important when you actually have some sort of workloads that cannot be containerized, when you have workloads that live outside of the world of Kubernetes, because not everything has to run inside of Kubernetes as well. And you just need a way to get to it. You need the logic built in. That's where BGP is coming in. If you really want to understand some of that logic a little bit better, go check out the last video, the last stream that we did. It'll actually go into a lot of detail around how BGP works and just a little bit more of the setup. Now, with respect to pod IP pools, like I was talking about the IPAM piece, when you actually specify a pool of IPs you want to hand out, like as addresses to your pods, what that actually can do for you is you can actually take that and then share that network information, the pod CIDR information, back to the rest of your physical network or outside of Kubernetes. And that's going to be done through BGP. So there's a lot of cool things here that you don't have to sit here and do. You don't have to figure out little bits and pieces. You don't have to mess around with Docker networking. but I want to show you quickly what some of these configurations look like, and then we could take a look at all of this in a terminal or in a little environment. By the way, if you've got any questions, welcome back, Dan. If you've got any questions, feel free to just throw them into the chat, and we'll answer them at the same time. If you want to let us know where you're coming in from and what you're working on this week or what you're most excited about this week, let us know. And while I'm going to just dig through some stuff here, Dan, what happened?
My Hackintosh panicked, so I clicked my trackpad and both monitors just turned off, which was nice. Not a good start to a stream.
Yeah, I love it. All good. So if you were to run this in your own environment, what you probably would do is just clone the repo. It's probably the easiest, and then go right to the directory of where it is. I don't think this is, it hasn't been updated in a bit, so I don't have to do a new refresh or anything like that. But notice here that we're updating the Helm chart, or we're actually using a Helm chart here, and we're actually using, Cilium doesn't show up here, but there's another section, or there's another lab environment that shows that you actually have to use Cilium. So if you are attempting this along with the container lab resource, kubectl, you'll also need make, you'll also need the Cilium CLI, and you'll also need Helm. Now, the make file here is just basically some automation for us. So you don't have to sit there and manually, plug out these command lines. If you want, you can. It's totally fine. This just speeds up the process for you, so you don't have to do so much. Effectively, what's going on here? By the way, I'm just going to say hello to Nistin. Nistin's one of my university friends from like way back. It's funny to see him on Twitter. He lives in an entirely interesting space, and he does a lot of conversations around AI, and some of them more like deeper work that's being done that a lot of us like don't see. So if you're interested in seeing what he's up to, go check him out. Thanks for coming by, Nistin. Okay, so back to the configuration. So this make file here is going to go ahead and deploy a kind cluster. There's a container lab command. I'm going to talk about that in a second. It's also going to taint the node so that you can actually go ahead and run workloads on the control plane as well. And then we're going to create a secret here. Super secret. And it's called Cilium 123. Now, this is important because when you're actually using BGP or the BGP control plane, when you have to have neighborships form, and Nistin's here is going to remember this as well, because we actually learned a lot of this when we were in school together through like some of our CCNA or CCNP courses. I can't remember. When you actually want to exchange updates between two neighbors, you absolutely can do so, but it would be like by default in an unrestricted manner. Like there's no authentication, there's nothing. So what we're actually doing here is we're creating a secret for that authentication to be in place. So if a neighbor wants to exchange information with another neighbor, a BGP peer, it's going to have to authenticate, right? Now, obviously, this is too easy of a password and easily guessable, and this is how hacking can happen. And you could just basically like manipulate the global or your private BGP routing table. And LinkedIn user, is there a link to the previous session? Yeah, just head over to the YouTube or my YouTube channel, and you should be able to see it there. And you'll see like session 10 or like episode 10, where we dig into like BGP internals, as well as just the previous way of how BGP works. Anyways, you need this authentication in place because on the router side, there is going to be a router that we interface with, and I'll talk about that in the container lab bit, that effectively needs to authenticate and make sure that it's a secure neighbor. And then we've got the Helm bit to install Cilium. And there's some values as well that basically enable BGP and some other bits too. If you're interested, you could take a look at that. And then there's some commands to just lifecycle the actual deployment so you can destroy it once you're done. And then there's actually one make command that you run so that you deploy the BGP process and BGP process is deployed. You just need to turn it on and set up your neighborships and specify your routes and whatnot. But that happens here, and we can take a look at some of these configs. So to start, not this one. Wait. What is this cluster config? Actually, hold on, not this one. Let's take a look at the topology for a second. Because in your mind, you're probably thinking like, how does this all look? What does this all mean to me? How is this connectivity looking? And Dan, you're more than welcome to draw this behind the scenes while I'm going endlessly through this. And Niston's got a comment. My retirement plan is to become a BGP admin. It's like learning COBOL at this point. It's never going. Totally true. Okay, so Container Lab is an interesting environment because if you've ever worked with something like GNS3 or Dynamips, the idea is to simply give you a virtual routing environment. Yeah, so I'm only showing a GitHub repo at the moment. Oh, I guess I didn't change my... Hold on one second. Give me a second. I think I messed up my sharing. Share screen, window, here we go. That looks better. Okay. So this is the topology file for this system called Container Lab. And effectively, it'll help you build a virtual topology of network devices, of network routers, of network systems. So you can build virtual networks and simulate them and lab them out in a sandbox-like environment. The nice thing about this is it all runs in Docker. Like, that's the beautiful thing about it. Now, one thing to note is if it's running in Docker, it's also going to take advantage of the usage of Docker networks. So Docker networks actually simulate our broadcast domains for us. So if you wanted to simulate like point-to-point links between network devices, that's the best way to do it. It's actually very challenging. It's not very easy to do manually. So Container Lab makes this super, super easy. Another thing you can do is, and I'll come back to the entire configuration, is if you see this links section at the bottom, I'll make this a little bit bigger so you can all see. The links section here just basically allows us to map endpoints together or create a pair mapping. So if I see router 0, net 0, and then I see server 0, net 0, what that's telling me is the net 0 interface of router 0 is directly interfacing with the net 0 interface in server 0. And then you see the same with router 0, net 1, and then server 1, net 0. Basically, when you see net 0, that's usually indicating the primary interface of a service or a server. And then these are just more interfaces on the actual router itself. So if you were to visualize this, you could think of one big circle and then 3 lines coming out of it. And then at the end of those lines, you have like a device. And that circle is representative of that router. So having said that, let's look at the configuration for a second. Now, Container Lab reads this YAML file and then processes it and then goes out and spits out a topology. What it's effectively doing is it's actually going out to build the topology with some information you provided. The first bit of information is we're actually deploying a router. So that first router is an FRR router. It's a container image. It's going to deploy it into Docker. And then we exec into the container to give it some initial configurations, meaning if it's going to have 3 interfaces, it's going to have 3 separate IP addresses on each one of those, 1 per interface. Effectively, they're separate subnets altogether. So you could think about the fact that each one of these endpoints represents its own network. There's some other bits that we also run to do some IPv6 forwarding. So you also notice that we've also assigned some IPv6 addresses to these interfaces. Notice that these interfaces can have both. That's totally fine. And we also have some static routes here just to send traffic to some no destinations or like destinations that just don't exist. Now, one of the things we also do is once we've got the base router configuration up and online, we're actually going in to mess around with the actual configuration of the router. We're actually adding more configuration. So you could do the same thing here, like in this same exec command. But this is just an easier way. If you wanted to modify the BGP config down the line, you could reload the router conf as you see fit. Now, a couple of things are going on here, right? We're actually enabling some debugs for BGP in case we need to troubleshoot what's going on with BGP, neighbor establishment, for example. Where is it stuck in the establishment process? Maybe there might be a lack of TCP connectivity and a firewall might be blocking it, or maybe the, authentication is off because someone misconfigured a password. Now, I also have some other bits here too. And this is something I discovered. I didn't know you could do this, where you could actually create a peer group. And basically you define those neighbors as part of that peer group. In this case, it's called Cilium. And here, what we're doing is we're just defining some of the bits for Cilium as our neighbor. So what that means is if I define a remote AS as external, if I'm defining a password, this gets applied to both of these neighbors. Now we've defined our neighbors. One of the things is if I go to the Cilium side, I kind of have to do the same. I kind of have to define my neighbors as well. Leon, I see you have a question. Is there a link to the LinkedIn Live? Yeah. If you go to my profile, like in LinkedIn, you should be able to find it like very easily.
It is, I guess, worth noticing. You mentioned kind of the topology. In Container Lab itself, there is actually, you can drop these topologies in there and it will actually show you what that all looks like. So you'll have effectively our router at the top of this 3 interfaces, and then each of the servers, which is basically plumbed in to those through the link section at the bottom. So you can kind of see all of that.
Exactly. Okay, so a couple of other things that we're also going to take a look at here is there's a few server configurations here, and these are just the endpoints that we're defining. What we're effectively doing is we're just creating these endpoints so that if we want to test out like connectivity of sorts, we absolutely can. I'm curious, is this where we define our, yeah, here we go. BGP, control plane, dev, pod IP pool, control plane, and worker. So if you notice here, these are the 2 control plane and worker nodes of our cluster, which we haven't created yet. We're going to create it very soon. So let's go ahead and take a look at some other bits as well. We looked at topology.yaml. Let's take a look at the values file. Just notice that BGP enabled, and then there's actually a flag for V2. Now, I was actually, I think I saw this somewhere that 1.16 is it available yet? Is it GA?
End of this month, I think.
Okay. So we're actually showing y'all a cool feature that isn't GA yet, but will be in like a few weeks. So y'all have a head start now. Good luck. And then ping Dan if anything goes wrong.
Yeah. No,
so let's also take a look at, I think I specified the cluster config too. Yeah, all right. So if you see this cluster.yaml, there's a couple of other things that you're seeing here. So we have a kind cluster, and we have a pod subnet defined. We have a service subnet defined. And if you notice, we've actually assigned some additional information. We've actually labeled these nodes with an autonomous system number and its IPs. Because here's the thing, your BGP speakers will have a router ID. So it's going to have to default to some of these IDs, or it's actually going to have an ID here. Otherwise, whatever IPs assigned to the device is going to pick this. The other thing too is we're actually hard setting and statically configuring these cluster nodes. So the worker node is going to be 10.2. It's going to be 2.2, I think, and then the control plane node is going to be 1.2. And notice here, where's the service, or actually the cluster side, or it's probably not here. But anyways, the idea here is that once we statically configure these entities, when we spin up the cluster and we do like a kubectl get nodes -o wide, you'll see these hard set IPs already there. So it doesn't assign random IPs. This actually helps with predictability, especially as we're trying to, stand up a neighborship. The last thing I'll show you before I actually deploy anything is the bgp.yaml config. So we can take a look at some of the bits here. So notice that there are two pod IP pool configurations. One is for IPv4, the other one is for IPv6, and there's a label called blue. So if there is a pod with a label blue, it's going to get this IP address right here, or an IP from this pool right here. Same applies for this one with a label called red. And then we've got a BGP config. This BGP config, we're effectively defining our BGP peers. Now, if you notice, our local ASN 6501 and our peer ASN is 65,000. The fact that there are two different ASs means that we're talking about eBGP here, eBGP or external BGP running, because we have different autonomous systems trading routes, which means that the exchange of routing information and the updates are going to be smaller but impactful. So the initial update will send out all of that full routing information, and then any subsequent updates will be tuned accordingly. We're just defining its address, and interestingly enough, we're only using the IPv6 peer address. I don't think we could do that previously, right? We weren't able to use IPv6 as a peer address in 1.15.
I mean, there's no reason why we couldn't, because it's Go BGP that's doing all that under the covers,
Okay.
and it should all just resolve. I think it was probably just as it grows in functionality, adding an IPv6 support, basically.
Ah, gotcha. Okay. Okay, so there's another section here, the BGP peer config, and this is where we're actually defining what we're advertising to our peers and the specific pools. So we're just advertising our pod IP pools for IPv6 and IPv4, regardless of whether it's the red or blue label. We're also defining the authentication secret, which, if you recall, the secret file or secret we created earlier on, or that we create when we're deploying the cluster, that's effectively that same secret here. And then we've got some advertisement configs as well for the pod IP pools. We've got a daemon set for a curl command, which I don't think I even use in this. I don't know why it's here. It in the documentation or here, it doesn't even define how to use it. But anyways, let us go ahead and stand this up. And feel free to chime in, Leon, Dan.
Yeah, I mean, it's as I say, we're all going to be using Container Lab to actually host the infrastructure for running the BGP itself. I suppose if you're not wanting to do Container Lab, you can quite easily stand up FRR itself. Alternatively, there are things like MikroTik virtual machines or Juniper Vios. I think you can probably do BGP with that as well. So you can effectively have that as a VM that you'd like to peer with. So you've got a lot of different options for doing this sort of thing locally. Ultimately, once it's stood up and configured, you're effectively going to just want to peer with it as you would do with FRR in Container Lab.
Yeah, one of the things that I'm going to be working towards is just procuring a couple of physical routers. Maybe, Dan, I might ping you about that a little bit later on, seeing if we could get access to some of that Cisco gear.
I mean, if you do know where to look on the internet,
yeah,
there are things like, I think it's called the Titanium emulator, which is effectively it runs NXOS, which is the Nexus brand of routing and switches and whatnot, which is the kind of the more later versions of networking gear. So it does exist out there.
So I actually just want to point out where I am. Now, I actually cloned the Cilium repo, and I'm just right here in the Cilium contrib container lab BGP v2 pod IP pool folder or directory. And if you look here, there's actually a number of resources here. There's that make file, there's the bgp.yaml, the cluster.yaml, the topology, the values. So we could go ahead and just run this, and it'll go ahead and deploy a number of things. And this is all in my home lab. So I'm actually pretty excited. Actually, I cheated. I tested this all out last night and earlier in the day just to make sure it was all working, and it all worked just like flawlessly. And that's what I love about like when people actually spend time to test things out and make things work. It just comes out clean, and it makes the experience very nice. So it's going ahead and deploying a kind cluster, just a control plane and a worker node, and we'll make both available to be schedulable. And then we're going to go ahead and just deploy the pod IP pools as well as the BGP configuration. What it is going to also do behind the scenes is it's actually going to be deploying Container Lab and that topology we just took a look at. So we'll get to even see the configuration from the container side as well as the and what the router looks like. And then we'll look at it from the lens or the perspective of Cilium. So looks like everything was deployed. Let's just give it a few seconds because I immediately tried to run the make apply BGP command, and then like everything failed. And then a minute later it worked. And it's just because the Cilium pods are just coming up online, and it just takes a minute.
And it's worth noting, I suppose, that the make files have effectively got one of the dev branches of 1.16 hard coded in there. So
yeah, that's true too.
Yeah, if you look at the bottom there, you'll see it's running 1.16 dev blah 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 blah. So I wouldn't use this in production right now.
No, exactly. And the point of this is just to illustrate like the functionality. But if we go ahead and take a look at pods -a, Cilium is running. One of those pods is going to be running eventually. In fact, I do have Cilium here as a CLI. So if I take a look at the status, telling you this worked yesterday.
There you go. Does that change? No. Still 5.0.
I think it's starting more. Yeah. I'm just waiting for CorDNS to come online. This was not supposed to happen. Literally everything worked like flawlessly.
That's strange. I wonder why they've not come up.
I could just kill it all again and then give it a shot, but that's fine. Make destroy. You know what? I'll just reboot the node too. I'll reload my environment. I was like, wait. I'm not waiting. So while that's on its way to shut down, so like I was describing, what it's supposed to do is actually, and it'll work. Don't worry. I believe this will work fine. What it's supposed to do. Go ahead.
Oh yeah, I do believe those Cilium. So the Cilium pods that were in the running state, effectively, it can well be that if you've had Cilium up and running, you've destroyed it. When it comes back up again, it may need to clear up any VPF bits that are still attached and things like that. So it will eventually get to a stable state if it's already been running before. Sometimes just a little bit more patience can be needed if that is the case.
Oliver's like, you didn't sacrifice to the demo gods.
True.
Oliver and I used to work in the SD-WAN business unit at VMware years and years ago. Great to see you, Oliver. So while my system is rebooting, come on, super admin, log in already. There we go. Ooh, I love how fast that was. Nice. Okay. CD, Cilium, contrib, container lab, BGP, v2, pod IP pool. Okay, and then let's just double check something. Pods, good. Nothing is there. Ooh, Leon, if you've got background noise, you might want to mute. All right, let's make deploy. Crossing my fingers that this works. Are there other things that you can tell us about what's going on with the BGP control plane on the roadmap, or is that super hush hush?
I mean, there's a number of things that are kind of open source. There's a lot of things that are kind of being asked for in the BGP realm as such. So, kind of when we first released BGP with Cilium in 1.13, it didn't support things like MD5 passwords or anything like that. So we didn't support any sort of authentication to begin with. It was basically, like if you know a neighbor, then you can kind of peer with it and things like that. So it's an ever evolving area that's kind of gaining quite a lot more demand in kind of Cilium space. So, I don't know if and when it's being added, but there's requests for things like BFD, so much higher failover in the event that like a link goes down or a peer disappears. There's been changes to kind of the timeouts to reduce those so that things are a bit quicker in the event that something isn't behaving as expected as well. As we've kind of looked at today, we've re-architected the entire custom resource set in terms of how it all works. So it's now a little bit more kind of spread out and things like that. And one of the other things really that has been discussed is would it make sense for us to kind of push this as a standardized way for doing things like BGP networking across the wider Kubernetes community? So, things like MetalLB do BGP. There's other load balancers that also will do BGP peering and advertise services, but they all have their own way of doing it. So could we standardize against all of that and have kind of all of the different vendors that do this sort of thing? You're kind of like gateway API with ingress objects. Do we have something that would be the same for things like BGP peering? Potentially layer 2 for ARP and things like that as well.
It is still struggling.
It is struggling, isn't it? I wonder why.
No clue, but I'm going to take a look at. It says unable to retrieve Cilium endpoint, error with exec request. What did I change here? Did I, is it because I'm running, it's because I've got iPerf installed? No, that wouldn't cause it.
No, I don't think so.
Yeah, because I deployed iPerf after I was doing some stuff here, so.
Could you do a kubectl logs on one of the Cilium pods to find out why it's exiting with code 1?
Yeah. Actually, here, I'll do this here. But waiting for IPv4 pod cider pool to become available.
So have we not applied the pods? I wasn't aware that it was going to sit and wait for those pools to be available if we've got BGP enabled.
Well, it won't even process the make BGP. Let's see what happens. Let's see if it cries less. Still, that didn't really do anything. It shouldn't have really done anything.
Wait. One of them's now restarted.
Oh, oops, wrong one.
There you go. So if you've got BGP enabled, for whatever reason, they must hang in a wait loop until the pools are created. That's something to be aware of.
That is very interesting. I didn't run into this yesterday.
I thought you said you did. You applied everything and got.
Yeah, I applied. No, I didn't run into that particular issue
Right.
but at the same time, maybe I wasn't even checking for that because it never really checks for, like, I mean, going through that one exercise, it didn't ask me to check for the Cilium status. It just asked me to proceed. So maybe this is user error on my part. That's interesting. That's a good point to know, though. It won't come online until. See, look, now that curl is running. That's interesting. Okay. There must be something in that config. I got to go back and look at it. But all right, let's proceed because I wanted to cover some stuff here. So we did a Docker PS. You'll notice that there are a few containers that we have. We've got these NetShoe containers. I don't care about them at the moment, or maybe even today. But we also have an FRR container as well as our BGP workers are basically our cluster. If I do a kubectl get nodes -oy, remember what I said earlier at the beginning or closer to the beginning of the stream when I was explaining the configurations of the cluster? We statically assigned that IP address to the control plane 10.0.1.2, and it's a /16, so it'll be in the same subnet as 10.0.2.2, meaning these two should be able to communicate with each other, but they're also their respective router IDs for BGP, which means that they're going to form those neighborships. What's interesting is it shows the IPv4 address, but not the IPv6 address that was defined. If you could describe the worker, you could probably see the actual full addressing, but no, we're okay here. So let's take a look at something. Cilium BGP peers, and notice that we've got a peer here, right? And its autonomous system number is 65,000. Its address is FD001001:1. For those curious about that double colon, that usually indicates that there's a bunch of zeros in between, and you could short form your IPv6 address, making it more readable. Now, there's so many other like hacks to IPv6 as well that I think I should spend a stream on just talking about it. The session state is established. Oh, Niston saying, side note, Z shell is often not compatible with batch scripts that use wildcards. Probably. That's probably why I ran into an issue, or maybe I didn't. I don't know. I don't know what that's in reference to, but let us know. Give us more context. So we're exchanging routing information because as long as we see established, that means the peer was successful. The peer neighborship was successfully formed. And we're even seeing we're receiving networks and we're advertising networks as well. Oops. So if I did a Cilium BGP routes, I think that's a command. Yeah. Okay. So you can see that these are the prefixes that we're sharing out because they're local. They're not learned. So I'm trying to remember the command. Actually, I should be execing into one of the Cilium agents, I guess, right? To see what the route table looks like. Or is there another Cilium command? Cilium BGP summary?
Yeah, I mean, a lot of the new stuff has been added into the Cilium binary. It makes it a lot easier to actually understand what's going on.
Cilium BGP summary.
No,
there's only two. Ooh, interesting. Okay, that's fine. Let's go take a look at the other side then. Let's go take a look at the FRR side. So there's a nifty command that I learned over I guess the last year. Let's just do a Docker PS one more time. Docker PS. So this is our FR router. Its name is CLab BGP v2 control plane dev pod IP pool router 0. So let's just copy that, and then we'll do a Docker exec -it, the name of the thing, and then btysh, and we're in the router. So if I did a show run, we output the running configuration of the router, which is what we saw much earlier on. My Cisco friends, if you're out there, if you're watching, Oliver, I know you know this stuff very well. This must be very familiar to you. Show IP BGP summary. I think that's a command too. Oh, look at that. We're seeing neighbors. We're receiving messages. We're sending messages. Show IP route BGP. Does that actually work? Yes, it does. Oh, beautiful. Now I'm learning about BGP routes from my neighbors, which are my kind nodes, right? So it's really cool that we're able to interface. And I think one of the important things about the way BGP was done initially was with MetalLB, I believe, right? And it was a lot more extra work to get up and running. And then the second iteration, which was like a pretty recent reiteration of the BGP control plane, exposed us to like the BGP virtual router config, the the Cilium BGP peer I think peer config or peer routing config. I can't even remember what the previous CRs are anymore. But just a bunch of CRs. So actually, let's take a look at that.
You're still in the router. I mean, I think the biggest, not really a complaint, but like people really wanted to get their hands on it, and it's really hard, or it was quite difficult to actually understand what was kind of happening under the scenes when we first released it. So as you've seen, with the Cilium CLI now, we can see all the routes that are being published. We can see all the peering information between, the Cilium daemon sets and the top of rack switches or FRR or whatever it is that's been doing. So there's been, a lot of work in being able to make it easier for troubleshooting, for understanding the topology, for actually being able to see if things are actually up and running. When we originally were just kind of packaging MetalLB, we couldn't really support MetalLB. We had no kind of control in the direction of MetalLB. It became a bit of it became technical debt to a certain degree for us, kind of giving this as the only tooling for people to do the BGP peering that they're after. So, this is just an evolution of us kind of being able to have a bit more understanding and give end-to-end understanding of what's kind of happening there.
Yeah, you're absolutely right. Like, I think we're going to see more and more advancements of how BGP can be used, and it's going to lend its way to doing some patterns that we were trying to adopt many years ago that we can now adopt very easily. I'm just waiting for the Multis support in Cilium, so let me know when that happens.
I mean, so funnily enough, there is a multi-adapter, multi-interface part to Cilium, but unfortunately, it's not been something that's been developed from the open source community. So hence, it's unfortunately not in the open source variant of Cilium. It's only in the enterprise version of Cilium.
Yeah. Okay. No, that's good to know. Okay. So what was I going to do? I was going to run a kubectl something. Oh, yeah. Actually, no, I don't remember anymore.
Sorry, I've completely destroyed your train of thought there.
That's totally fine. Okay. Okay, let's destroy this and let's do the service one quickly, because it's actually almost similar. So I'm going to do a make destroy. We're going to get rid of all of this, and we're going to go ahead and deploy one of the other ones here. So
I think to a certain degree, services are kind of largely what people have been wanting this for, to a certain degree. To basically give you that load balancer support for Kubernetes services and apply that to the rest of the network.
Yeah, so there's a few things that are going on here. I think it's worth taking a look at some of these files quickly. The make file here is just going to go ahead and create a kind cluster like it previously did and do some of the same things. Here's where that Cilium status comes in because it wasn't there previously, and this is where you're going to need that Cilium CLI. Notice, though, we're actually going to go ahead and create another topology. The topology actually looks very similar to the previous one. The only differences that we're going to take a look at is if let's take a look at the cat BGP YAML file here. We're doing some things here. We've got two namespaces. We've got our BGP cluster config. This is our locally significant config, as well as what we're peering out to. Here's what we're going to specify for our peers and how we're going to communicate with them. Look, we've got graceful restart enabled as well. And then what we're advertising. Oh, here we go. So we're advertising our services. And then we're also doing this for our load balancers as well, or our load balancer IPs. So there's something, yeah, there we go. So as long as we have this, we're going to advertise both the pod sider as well as the service sider. Okay, so that's really it. I mean, the only other thing I want to take a look at is the service YAML and then the LB-IP YAML. So let's take a look at the service YAML. So all the service YAML is doing is we're just exposing two services. One's with, they're both node ports. Okay, so we're exposing node ports, and we're probably going to just distribute those addresses into the BGP process. So we should see this show up in FRR. And then we've got a deployment for it, so we're good to go there. Now the other one, the IP. Okay, this is the important one, right? And I think this is kind of an interesting one. I've always questioned why we do this and why we still have this naming convention. And I think I brought it up once before. The load balancer type. We're not creating a load balancer per se. I think that's something we just defaulted to a long time ago because we wanted to expose a service externally. Where did that name come from? Just curious.
I mean, there's Tim Hockin, I think, not long ago, did this big thing about actually I think it was a KubeCon talk he did where Kubernetes services unfortunately are just massively overly encumbered with a lot of naming types and things like that, and ultimately they really do need services need pulling apart and readdressing and things like that. The concept of service type load balancer largely is more for cloud-like environments where the load balancer does exist, and we basically just need a way of wiring and plumbing things up so that that IP address that's created of a service type load balancer is the service IP address in the outside world, and ultimately plumbs kube proxy logic in. So when traffic comes in to the cluster, hits the service type load balancer IP address, kube proxy knows then and has the logic for it to then go to pods that sit underneath the selector and things like that. It's always been kind of amusing because service type load balancers don't really do any load balancing. It's more of a VIP than anything. Kube proxy can do some load balancing under the covers. So yeah, it's a bit of a funny one, really.
Well, that's just it, right? Like cluster IP as well as node port are doing the same thing. They're just abstracting and creating a VIP. It's not like, they're quote unquote, they are load balancing for backend services. But it just like kind of breaks that naming convention altogether.
Yeah. So they're internal, whereas the idea between a load balancer is that it's a publicly facing address that the outside world will use in order to get into the Kubernetes cluster, whereas the other stuff is largely just internal IP addresses.
Right. Okay. So in our case, everything is working here. I'm curious. I got to go back and see what was different between that last one and this one. Maybe it was something to do with the pod IP pools, and maybe because we didn't specify it in the cluster stand-up, but that's okay. Anyways, in this situation, we want to advertise our service IPs. So what we've gone ahead and done is we've deployed our cluster. We're going to deploy BGP, and then we'll apply the service as well. And then we'll apply the load balancer. Done. Okay, so let's go ahead and take a look at everything. Get services dash a dash dash show labels. I could spell labels properly. Okay, so let's take a look at the fact that we've got a few namespaces here. We've got some services here. Some are load balancer based, some are node port based, and you can pay attention to the IP addresses as well. The load balancer IPs are not in a conventional subnet, so it makes it easier for us to identify on the router side. But the actual node port IPs, this is something of an artifact that we've hard coded somewhere up there in one of the configs I showed earlier on. And then we've also got labels affixed to them so that we're telling the BGP process to advertise and catch these IPs and advertise them into the BGP process so our peer can learn about them. So that's all good and ready to go. We've even got a few services deployed as well, which we don't overly care about because we're not really going to do anything. We can test curl if we want through the net shoot, but the point of the matter is, like, we really want to see that the service IPs and load balancer IPs are showing up on the other side. If it is Cilium BGP peers here, I can see that I have established a neighborship with an upstream router. I have sent some routing information, and I've received some routing information as well. And then if I Docker PS and grab the name of the node or container, and then do a Docker exec-it, name of the container, VTYSH. By the way, VTYSH is actually similar to the virtual terminal when you're like SSHing into a box, or not SSHing into a box, when you're taking your console cable almost and connecting it directly to the router itself. So if I do a show IP BGP neighbors, I see that maybe there's a summary command here. There is no summary command. Well, I know that my neighbors are established, and I've got a couple of them. Show IP BGP summary. Why do I keep doing that? Show BGP summary. There we go. Okay, those are my neighbors, and then show IP route BGP. What should I see here? I should see exactly what I hope to see. Actually, I'm missing a route. Which route am I missing? Let's go look up.
Which one was missing? There's only four that should be advertised.
I think this was advertised as a unicast route, like a /32. 20.0.10.1. 20.1. Let's see. I've got one of them, 20.1. See? Yeah, it's a /32 route. Where's the other one? Let me try that again. Show IP route. There's only one of them. Did I not advertise the other one? Let's take a look at. Actually, hold on. Let's exit out of here quickly. Let's cat the BGP YAML.
I think if you look at the docs there is something to do with one of the load balancers having external traffic policy local. So there's no endpoint to it. So it won't be advertised.
Oh, that's a good observation. Yeah, where did I see that config? I remember seeing it somewhere. Was it under the service.yaml?
So it's tenant blue is the service.
Here we go. There we go.
Yeah, so the red one. So basically,
So that
with
one should...
with it being external traffic policy local, yeah, it won't. It probably won't have an endpoint, so there'll be no local pod running for wherever it's running to.
Mm-hmm. That is interesting. Ah, here we go. That's it. That's what I was looking for.
Mm-hmm.
Okay. That's an interesting one. I've never
So
seen
what
that.
I think that probably means is that the worker will be advertising the routes to it because it'll be running on the worker, but on the control plane, the workload won't be running, so it won't be advertising an address to it.
What is the command to show the BGP routing table specifically, not the IP routing table? I can't remember.
I mean, there's show BGP IPv4 or something like that, I think.
There's 20.1, but where? So it technically, I guess it doesn't. Okay, so that flag is what disallows it from being advertised, is what you're saying.
Well, what I'm saying is the one address, which is going to be the control plane, isn't going to be running the workload, so it won't be advertising the route to it because there's only one pod on the back end.
Oh, right. Okay.
I think.
I want to dig into that a little bit more and explore some of these. Like, actually, what happens if we do this? What was the... I want to edit this service quickly. I want to see if modifying that, where is that external traffic policy?
It's just under cluster IP, so go down 5 or so. Yeah. So that's cluster instead, or delete it.
Okay. That's gone. See if it breaks anything. Will you look at that?
There you go.
Haha. See, this is why you experiment, right? You trial and error. Okay, that's good to know. I learned something new today. That external traffic policy set to local disallows that route from being advertised. Okay, now you know. This is a great place to wrap up. Okay. All right, folks. Well, we are basically 6 minutes over time. There's so much more to explore with BGP. There's actually another. Let me actually stop sharing. There's actually another module that talks about multi-homing, and sometimes you'll do multi-homing in case you want to create higher availability in your data center environment. So you'll have multiple top-of-rack switches. That also increases your available bandwidth, makes all available paths useful. I don't know if it's an official ECMP capability, but maybe I got to look into that, and maybe we can explore that later on. But in any case, here's what we really looked at. Like Cilium 1.16 and its flavor of BGP has a lot of enhancements. And the idea really is to create a lot of flexibility in the way you can allow some nodes to participate in BGP, as well as what workloads and subnets you're advertising. And we you got to see it. Like, heck, you can go to that repo and try it out for yourself. You're going to need Docker. You're going to need Kind. You run this all in Linux. You're going to need Helm, kubectl, and the Cilium CLI, and make. Just clone the repo, go to the directory, and then run the make commands, and you'll have these environments up and running in minutes. And you can test it out for yourself. What's really cool is because Container Lab is very flexible, you can even modify that topology file if you wanted to add more endpoints or make some changes as well. But the two areas we talked about, how to advertise pod IP pools, and then how to advertise those service and load balancer IPs into upstream BGP, so your extended upstream network or physical network can see what's going on in Kubernetes. Dan, Leon, anything to add?
No, I think we've kind of covered quite a lot of it. It's good to see that we get a much greater understanding now from the Cilium CLI in terms of what's actually kind of happening there. It's just getting it into people's hands, getting people playing with it, getting feedback, and helping us kind of evolve this BGP functionality and take it to more places.
Exactly. So, Leon, you've been quiet all stream.
Yeah.
What's up?
Yeah, I just learned a lot of new things. So just looking up the terms and all that. So still quite new to me, but it was fun. Yeah.
Fantastic. All right, folks. Well, I haven't scheduled the next one yet, but what we'll probably start digging into is some of the API stuff and talking a little bit about API communications and or gateways and ingress and all of that magic comes into the mix. So hope to see you soon. We'll be in touch and we'll let you all know. Take care, everyone. Have a great rest of your week and day and everything. But yeah, take care.
Bye.